What's up, my friends? Welcome back. In this episode of Remodeling My Home, we'll see how to make the electrical box here in Spain. And I say that because the laws and the voltages and the breakers are different in each country. But since I live in Spain, this will be only for Spain. So I'll explain you all the circuits, how to do it, how not to do it, and all the bad jobs that I found in this home, what each part of this breaker will do, and we'll make the 5 more typical circuits here in home for the washing machine, the lights, the outlets, and so on. So I will go over the colors and the laws and the maximum power that we have here in Spain, all the connections of the breakers and safety. And by the end of this video, you should know how to make this electrical box by yourself and safely. That being said, let's get started. Check this out, guys. Even inside of this motor, we have a tiny PCB. Nowadays, PCBs are everywhere. That's why I want to talk about the sponsor of this video, PCBWay. Because if you have some kind of prototype or you are working on a project, if you want to make professional PCBs, you should definitely check their services for PCB prototyping, but also for CNC milling of metal parts, of mold injected parts of plastic or 3D printed parts, and much more. I work a lot with printed circuits, and I think I've made more than 100 PCBs, and each time that I use their services, I get very good results. The tracks are perfect, the VS are perfect, everything is working nice, and the price are so low that even if you make some kind of mistake, you can reorder the PCB once again, getting better and better till you have a final product. So have in mind, the next time that you have a project with a PCB and you have some Gerber files, check the PCBWay for their services. And now let's continue with this video. What's up, my friends? Welcome back. Before we even start, I feel obligated, before we make this panel, this electricity box, I feel obligated that I should tell you that if you don't have the required tools, if you're not sure what you are doing, and the most important part, if you're not able to separate the main input power from the rest of the circuit, please leave this to a professional. So just pay someone to just separate the power from the outside on the street, because in this video we never have electricity connected to the panel box, because I've separated that at the beginning of the video. So in any given moment in this video, I'm not touching electricity. We do that at the end when everything inside of the home is ready. And by the way, before you even jump into the comments and say that I haven't made the measurement for the ground and all the tests for all the circuits, I won't do that now because you have to pay an engineer to come and make the testing. But even so, when I will be finishing the construction site, you are obligated to call an engineer to test everything. So I won't pay it 2 times, because you have to pay it first. It comes, and if something fails, you have to change it, and then you have to call it once again, so it will give you an electrical note that everything is ready to go. So I will be doing that at the end of the construction site. So if something fails in that moment, I will change it, because I don't want to pay 2 times the same thing. This is how I found this panel here. So I want to change it entirely. This is the one that has the phase connected. So this one is live right now, but it's turned off. So I will place it here separately, so we won't touch it. And now I'll remove everything here and restructure it in a new panel. So we have made the first step is to ensure that no electricity is connected to the rest of the house. So we have disconnected the main input, which is the phase and the return, and also the ground. So now we are sure that none of the plugs has electricity. Just to be sure, you should buy one of these control lamp. This costs only $5, and you should touch each of the plugs and the lights just to make sure that no electricity is touching the wire, so we could work with no worries. If you can disconnect the power from inside your home, probably you have to make it from outside your street, or if it's an apartment, from downstairs. But in this case, it's a lot better to leave it to a professional, because this is connected directly to the light of the city. So it's a lot more dangerous. As you can see, we have 4 homes here. So if I touch something bad, I will leave without electricity the 4 homes. Usually, if you have just one phase, you have a fuse here that you can take out. But in this case, since I have a triple phase input, we have 3 fuses. Let me just open this and show it to you. So this is basically what we have outside. We have 3 fuses for each one for each one of the phases, and also the neutral wire. As you can see, we have 4 plates here. So if you want to disconnect something from your home, you take this out. But in this case, we will disconnect the power from 4 homes. So we won't do that. And we also have these extra fuses, which just by unscrew it, you also disconnect the power from your house. So we should do that in case that you don't have the ability to disconnect it from your home. But we don't do that. Okay, so we have seen the step 1, which is to disconnect the power from the rest of the circuit using your general input of your home or the general input from the street. Now, there are 2 things that here in Spain we won't place today here in this video in our box. And the first one is called ICP here in Spain, which is the power control breaker. Basically, if you use more power that you have in your contract, it will jump. But nowadays we don't have to place that because now it goes inside of the counter, the electrical counter. So we don't have to touch it anymore. So they could change it whenever they want. And the other element that we won't add is the breaker for overpower, over voltage. Basically, if you have lightning or maybe too much voltage on the grid, they could break your stuff inside your home, your TV, and that will keep you protected. Now here in Spain, if you make a new home from scratch, that is mandatory to place it. But in my case, and this is a home that is already made, so it's not a new construction site, I won't place it. I've ordered it, and when it will arrive, I will place it for sure. But in this video, we won't add it. We'll have the typical circuit with the general breaker, the differential, and then 5 thermal breakers. Once step 1 is completed, so no electricity is connected to the rest of the circuit, we can take out the old breakers and also remove the panel and leave it like this, everything clean. Just 3 wires should come in: the phase, the return, and the ground, which by law here in Spain should be of 10 millimeters and should be the wires that are connected to the counter at the input of the street. So we have cleaned the old box, and as you can see, we don't have the breakers anymore, and you don't have to take into consideration these wires, these ones and these ones, because these are connected to the rest of the network, and we will use that in the future. But right now you should have your box clean as this one and only 3 wires input: the ground, phase, and the return. Now the first error that you will see is that here in Spain we should use blue and black for the return and the phase, and the return should be the blue one and the phase should be the black, brown, or gray. But in this case they have used the same color, which is not good, and I will show you why in a moment. Okay guys, so now that we have step 1, which is disconnect the power from the entire home, and step 2, which is to clean out the old box and leave only 3 wires for return, phase, and the ground, we are ready to install the new panel. Obviously it will be this one without the breakers, so I'll take out the breakers, measure the hole, make the hole, and then install this inside of the wall. And once we have the new panel, as you can see we have some holes here, we can pass the new wires and make the new circuit with new breakers, and I'll explain you which breaker will go to what circuit. So let's just do that. Okay, so step 1 was done, no electricity in here. Step 2 is also done, we removed the old box and we cleaned all the wires. And now step 3 is also done. We have made the measurements, we have made the hole a little bit bigger so this would fit. So we are able to place this inside. So as you can see now it's clean, we don't care about the rest of the wires that are going inside of the house, because the only thing that we care right now are the wires that are coming from the street, which are right now live and connected to this breaker, which I will leave like this because we don't have to touch it. Remember, black is for the phase, blue is for the neutral or the return, and the green with the yellow is for the earth. So right now we should place this inside and fix it more or less till we fix the entire wall. And as you can see, these boxes have these pre-made holes, and all you have to do is to push it, make a hole, and decide where you will enter the cables. Now usually here in Spain the power enters from the top, but in this case the home has the power coming from downstairs. So we'll have to make it to enter through here. So for this video we don't care about the wires that are going to the outlets and lights. This home was awful because all the wires were going to the same breaker, that's why the breaker was burned out. But we only care about the input, and then we'll make the 5 typical circuits here in Spain, which is one for the oven, 1 for the outlets, 1 for the lights, 1 for the water heater, and 1 for the washer. So we'll do just that, each one with a different gauge for the wire, each one with different amperage. So the panel is in place. I've just fixed it with some foam for now, because we will change this wall, and so we will fix it with some paste. And the only thing that inputs the panel are the wires from the street: the live wire, the neutral or return, and the earth. And that's it. So now let's just add the breakers, and I will show you what breakers we use here typically in Spain. Okay, the first breaker that we should put is this, called the general here in Spain, is the one that protects the entire circuit. But before we talk about what breakers we have and where to place it and how to configure it, I want to talk about this joint here. This is usually a joint for the earth. As you remember from the old panel, which was awful, the entire earth was just stick together with wires and then with some scotch tape, and that was it. But in this case, each circuit will need its own ground. So 1 ground wire for the outlets, 1 ground wire for the lights, another ground wire for the oven, and so on. So to merge it uniformly, we have this joint here, and this will get sliding here, the earth connection, the main earth connection here, and then each wire will go to each circuit. We have 10 outputs, and like that it will be a lot more organized. Okay, the first breaker that we should place here in Spain is so-called the thermal general breaker, or sometimes called just the general, because that's how it's called. And here in Spain, if you have a small house with a nominal power, which is 5,700 watts, you should place a general breaker of C25 or C32 amps. If you place it of C40, which is the one that we had before, which was wrong, that should be already elevated power. So the power should be of 9,200, I think, watts, and you should change your contract with your power supplier. But in this case, this is a small home. We have a basic contract, so you should place this one, which is limited to 32 amps. It's a C32, and this should be the first one that we should place. I'll also leave some schematics here, so you should know the general connection. We have the general breaker, the differential, and then thermal breaker for each circuit. And also I'll leave here on this corner or the other corner a video where we open this up, both the differential, the RCCB, and also the thermal breaker, and I show you how it works inside and why it has that function. Just so you know, the thermal breaker will save the life of the wire, so the circuit in your home, and the differential breaker will save your life. In case that you touch any wire, it will jump. Okay, the first breaker that we will install is the general one, so I'll place it right here. And now let me explain you something about the configuration here. I've already told you that usually here in Spain, the power from the street will input from above of the panel, but in this case, I have it from below. So that's why when I bought this, I made sure that this is a bipolar switch. That means that it could enter both on top or on the bottom. On the other part, I'll show you on the screen when I bought this, that the difference of price, this I think was 10 euros, and the normal one, which is not bipolar, was 6. So it's just 4 euros more. But in this case, that is not bipolar, you see that we have an N here, meaning this is the neutral wire. We don't have an N here, and this is not bipolar. So the power should always enter on top and output on the bottom. So let's just say that I add another breaker here. If I were to connect this on the top, I have to add wires still here, which is already uncomfortable because you fill the box with wires. And then I have to bridge it from here up here and then make connections to the rest of the breakers. So you have a bunch of wires. And if you remember the old box had the jump made with some of these thick wires, which is not just uncomfortable because it's very thick and you have to merge two wires in just one to make the bridge. And that is very dangerous because it could get out very easy, and also you have exposed wires. What I want to use, a brush, which is like this, a brush of copper, and this inputs exactly into the breakers and join all the phases and all the neutrals together. That's why for me it's very good to have a bipolar one to input here and then connect it to the next one, which will be the differential, and then to the breakers. So it will go something like this. So I've just added all the breakers in place just to measure if I will have space for all of them. And as you can see, if I were to place 5 for the 5 circuits, the differential and the general one, it won't fit. So I've decided, since the power will input from below here, I will add the general here. From above, I will connect it to the differential, and then I will use the copper brush and connect to all the breakers. And in this way, it will be a lot more organized, even if the general one will be down here. It's not a huge problem. So that's why I've changed my mind. So I'll move the general from here, below here, and in that way it's closer to the input. I'll connect the input from below because this is bidirectional, and then at the output I'll add the differential and connect it from below as well, because this manufacturer also show us that this is bidirectional. And by the way, this is a differential one, so it will make the difference of current between the input and the output, and it will jump, so it doesn't care if the input is here or here, doesn't matter. And then from the output of the differential, I will connect it with the copper brush to all the rest of the breakers, and in that way we have it all organized, so no loose wires here. Okay, so now we have the general part, and now we add one breaker for each circuit, and I'll have to place here a schematic for the most basic circuit of a home here in Spain. We have 5 main circuits, and by the way, each circuit has a different gauge for the wires. Obviously the lightning will use the lowest one because it doesn't use that much power, so we have 1.6 millimeters for lightning, for the light. We have 2.5 for all the plugs, and then we have 4 or 6 millimeter thickness for the wire if you use an electric stove. So basically we have 5 circuits: the light, the plugs with a different breaker, then we have the electric stove with a different one, then we have electric heater for the water with a different one, or the dishwasher, and then we have the final circuit, which will be for wet zones, like for example in the bathroom. So that being said, let's just add the breakers and I'll explain you the gauge and the power, the amps of each breaker for each circuit. Okay, so we start adding the breakers, and there is no specific order because they will all be connected in parallel here above. But in case that, for example, you have all your plugs output here and the light output will be here, don't put it backwards because then the wires will cross and it won't look organized. In my case, I'll start with the C10 for the lights, and this will go with the 1.5 millimeter wires. Then I have a C25 amps, and this will go for my electric stove, and this will go with wires from 4 to 6 millimeters. Then I have a C20 for my electric heater for the water, so this will go with the wire of 4 millimeters. And then I have two C16, and one will be for the wet zones because I have a dryer, and this will go with the 2.5 millimeter. And then I have another C16 for all the plugs, and this will also go with the 2.5 millimeter. So C10, 1.5 millimeter for the lights, C25 for the electric stove with 6 millimeters or 4 millimeters, a C20 for the electric heater for the water with 4 millimeters, and two 16s, one for the wet zones because I have a dryer there with a 2.5 millimeter cable, and another one for all the plugs with another 2.5 millimeter cable. Okay, so we have the general connected to the differential, and now from this output we have to connect all this in parallel using the copper brush, and all we have to do is to adjust the distance only for the first one because since they're all one next to each other at the same distance, if one enters, the others will also enter. And as you can see, this is a way better connection than using wires because wires don't have a flat connection, they move around. But this can handle up to 160 amps, I think. And as you can see, we have all the breakers connected together and there are no loose wires. All we have to do is to just tie the screws and then add the outputs with the corresponding output for each circuit. And that's it. Okay, and the last push, if you use an electric screwdriver, I recommend you to make it with your hand. You don't have to push very hard, but at least to make sure that it has a good connection. As you can see, each one has an N here, meaning the neutral wire is connected. Everything is perfect. The panel is ready. As you can see, the brush has an N, meaning that is the new one, the return. And then you have the face, each one for each output. We have to add the wires and connect it to my circuit. In my case, it was a mess, but after hours of searching, I have all the wires. I know where they are going. So I will add the different gauges for each circuit. I have my lightning, my electric stove, my water heater, and so on. So let me just add the wires and the panel would be ready. Okay, so finally, after a lot of work, all the circuits are connected to my home. Obviously, these circuits might be different in your case, but should be quite similar. As you can see, we have the 1.5 millimeter cable, the thick one, the 6 one, the 6 millimeters, and 2.5. And you can also pull them to make sure that they won't come out. And then we have a ground wire for each circuit. We have 5 of them. And the only thing that I don't like is that the ground wire that is coming from the street is so thick that it wouldn't fit there perfectly. So we have some exposed copper, which should not be here. So maybe I'll add some silicone or maybe a shrinking tube to just cover it. Just one more thing before we finish this video. You have seen that I had a small problem that I didn't have enough space to fit all the breakers on the same row. In case of that, imagine that you just want to add one more extra circuit for an air conditioning or something like that, and you don't have enough space. You can also use this, which as you can see, it says TPN or sometimes DPN, different to this, which is P plus D. And as you can see, where this occupies 2 slots, this only occupies 1. And we still have the N and L standing for neutral and live. So in case that you want to add just an extra circuit and you don't have enough space, you could also use this. By the way, guys, I've mentioned you that this home has a triple phase input, and usually all the homes have triple phase input, just that you have just one phase connected. But in general, all the phases, all the electricity is triple phase. That's why you see those huge electrical posts with 3 wires. So basically you have 4 wires because you have the neutral one, which is the return to the factory, and then you have the 3 phases. Between the neutral one and each one of the phases, we have 230 volts here in Spain, but between the phases, you can get up to 480 volts. And in my case, that's great because in the future, I want to add a plasma cutter, and that uses a lot of power. So here I'll make yet another panel for the workshop, just as the one that we have above, but instead of having a normal general of only one phase, we will have a triple phase general like this one. This is a general breaker. As you can see, only one phase is connected because the workshop still has light. And this is what I will do. I'll add this one, and then from here I will connect one phase to the normal stuff and triple phase connected to the big machinery. And this one is also made, but as you can see, they've made it on the wall. This is a very bad work, a very bad job. I'll remove all that and make a new panel here. And that should be for a different video. So guys, that's it for this video. I know that for some of you this doesn't make sense because this is a panel, electrical panel for Spain, so it might be different in your country. But anyway, you should now know how to make an electrical box here in Spain, why we use the breaker and why we use the differential one, what amperage goes to each circuit, what type of wires, how to place it, everything inside, what is the triple phase and how to divide that into just one phase or maybe use the triple phase input, and a lot more. I really hope that you have learned something new, and if so, consider subscribing, maybe comment below, give a like to this video, or maybe even support me on Patreon. In that way, I will be able to make more and more videos. Thank you very much, and keep up, guys. Hey guys, so that was another project, and I hope that you like it. As you all know, to buy all these modules, a huge help from you is from Patreon. So if you want to support me, you can support me there, but also just commenting below, giving me a like, or sharing this video, it will also support my channel. So thank you very much to all my patrons and to you guys.